Thank you, folks, for joining the call. I'm Sudarshan, CEO of Qubercomm. The topic for today is around home broadband connectivity. What are some of the emerging trends and how they have evolved over time? What is in store for the future is essentially what I'm going to talk about. There is a broad variety of technologies available. I don't think I'll be able to cover all of them. I cannot do justice simply because no one person has expertise in everything. So I've picked a few ones. If I have missed out any, it's not because I don't like them or I don't think they're good, but only because of the limited time. So that's it. Let's go into the slide deck. Next slide, please. So this is all from a ISP perspective that I'm talking about to say, okay, hey, what are the things that the ISP needed in order to deliver good quality of service to their customers? Rewind 20 years ago when Wi-Fi was very, very nascent. Back then, it was all still the wired technologies that were delivering broadband connection. And so what was needed was largely lifecycle management, things like being able to do firmware upgrades on those devices over the air and those types of things. Monitoring in order to figure out whether there are any problems, and provisioning to be able to configure remotely along the way, right? So those were the three key requirements that ISPs wanted. And if they had those three, they were quite happy. Fast forward 20 years and a lot has changed. Wi-Fi adoption has taken off rapidly, and we're now starting to have smart home devices also take up, and the users' expectations of connectivity experience is very different now than what it was back then. So with that in mind, what do we need now? What do the ISPs need? All the things that were needed in 2001 were still relevant, but now Wi-Fi and mesh management is important. IoT, basically the smart home connectivity aspects, how do you bring that all together? OTT and third-party services, possibly for even something like Wi-Fi management offload. And quality of experience. When I say quality of experience, the visibility into the client device and being able to say, hey, this is the type of connection it is experiencing. So those are the things that the ISP's goals are. That said, we will get into what are the options and challenges and walk through them. Next slide, please. So the options and challenges for the ISPs. One, the base problem is there's several technologies. There's cable, fiber, MoCA, DSL, Wi-Fi, PLC, some for the backhaul, some for the front haul. There is no one standard for everything. There is IEEE, there's Broadband Forum, there's Wi-Fi Alliance. All of them have independent standards for different things. And there is no one person saying this is exactly what needs to happen. And that is, I think, what made Wi-Fi industry so good, in that it gave flexibility for people to adapt it as they saw fit. So I don't state it as a problem, but as one that has enabled us to come this far. But obviously it comes with some drawbacks of itself. There are also open source industry driven options. RDKB, Purple Foundation are a couple that come to mind. And then there are proprietary options, EasyMesh and the likes. So these are all options that exist. How do you choose, what matters to you? Those are the things that the ISPs have to each make independent decisions on. Next slide, please. So I'll start, with the time evolution at that point in 2001 when those needs were there. 2004 is when the Broadband Forum decided we needed to do something about it. TR69 came about. TR69 basically, in a sense, is offering the three things that mattered: lifecycle management, provisioning, and monitoring. All these three are offered via ACS. ACS stands for Auto Config Server. So the gateway is connected to the auto configuration server, and from and through that is where all the configuration management and monitoring happens. That was the simplicity of what TR69 offered. They had a specific data model so that all of this could be consistently done by everybody. Moving to the next slide, please. Then comes TR181. This was back when Wi-Fi was still not too prevalent. And so when Wi-Fi came about, and with wide adoption of Wi-Fi, a new set of management and provisioning problems came about, and the data models that were used in TR69 did not offer the flexibility needed for this. So they had to adapt. Data model device 2 is what is essentially TR181. It is simply an evolution of TR69 targeted for enabling Wi-Fi platforms as well. Next slide, please. Okay, now fast forward further and come 2018, the world has changed in Wi-Fi adoption even further, and the Broadband Forum decided that a further evolution of this technology is needed, and so came TR369. You could call it as the next gen TR69. Essentially, if you go back to the things that I said are needed today in 2021 from an ISP standpoint, how do I address all of those? Wi-Fi mesh management. So basically, it's essentially managed services, outsourced Wi-Fi management, lifecycle management and smart and IoT devices. So it's not just the lifecycle management of the gateway, but the access points that are connected to it and the smart devices associated with it. Interoperability across providers, managing the quality of experience with visibility to clients, and in some cases also offer proxy for IoT devices, because IoT devices by themselves don't have the memory to run an agent for TR369, and so they could be proxied. Those are the types of things that have come about from TR369. So essentially, go on to the next slide, please. So how do they do this? All they are saying, all TR369 is trying to do is address the gaps that TR69 had. One, by having an always-on communication, and two, by ensuring that with the deluge of data that is going to come back and forth between the controllers and the agents, how do you optimize the utilization of the medium? And so efficient message transfer and robust responses was one thing, and that is driven by protobuf. That is the summary of what the how of TR369. So in TR369, you could essentially have multiple controllers and an agent talking to multiple controllers, all with different privileges. So for example, your ACS could be a controller, your mobile phone could be another controller. So that way, they recognize that there needs to be a variety of ways to control, configure, manage this solution. Next slide, please. Shrikant, next slide, please. Shrikant? Hello?
Yes, I'm on the slide managing gateways and APs at home, service provider expectations. So I don't know if Nadeem, can you see that?
Yes.
Okay, so Sudarshan, maybe just refresh. Let's see, hope that you can see it. Are you able to see it, Sudarshan? Looks like some disruption we have. So let's just give Sudarshan a moment.
Hello?
Yep, you're back on. Can you see
Hey, sorry, folks. Yes,
no problem.
I can see.
Go ahead.
So now that we've talked about all the things that are from a broadband forum perspective, let's go into the access point side of things. How do you manage gateways and access points? And what are the service providers' expectations out of the access points? One, they want to be able to do cloud-based management and control. They want to have flexibility to work with access point vendors and within access points across the home, within and across the homes. They want to be able to change, plug and play algorithms, solution vendors, so that they are able to do radio management. So they would have a part of their network managed by one vendor solution and another part of the network managed by another vendor solution. But how do you offer seamless experience to the A, user, and B, to the network operation center? Finally, they want to have the ability to analyze data about users' experience and proactively solve the problems. Next slide, please. So in order to do that, the mobile app for one comes into play, the app on the device control to the homeowner to manage their own Wi-Fi. But from a service provider standpoint, the cloud-based management and control helps them, offer, different types of services to the end user and do that incrementally. For example, at different points, they want to be able to choose what services want to be enabled and versus what services they don't want from a user perspective. That needs to be proactively managed, and those are offered through these solutions. So what are the things? Scheduling and managing, traffic, parental controls, then getting visibility into the network details on a per device basis, and the types of action that's happening on the network, and even to be able to do simple things like change the network user, the network name and password, SSID and password type of things. Next slide, please. So now, with all this said, we have mesh management happening from the cloud. What are the options there are for a solution provider to pick from? There are three primary technologies. IEEE came up with 802.11s for mesh. That is true mesh solution there is. WDS is a chipset extension, and EasyMesh is essentially what the Wi-Fi Alliance came up with. It sits on top of WDS. It uses WDS, but uses 1905 as a standard means of communication, so that across device vendors, across access points, there is the ability to communicate regardless of which vendor's device it is. This helps the ISP to be able to go mix and match devices based on user subscription, cost, all of those aspects. And if on top of this, if you're able to get the algorithms to be able to play consistently above this, that's the most useful thing from an ISP perspective, because it gives them the single way to manage the solution. Next slide, please. So what should a customer be aware of? From an ISP perspective, what should be the ISP looking for? Is the solution portable across different Wi-Fi solutions? How easy it is to manage the existing as well as the new deployments. Next, the intelligence that is offered by the algorithms, whether they are able to work seamlessly across Wi-Fi, or do they need customization on a per network solution basis or per box vendor basis. Third is, does it tie yourself to a specific protocol? For example, if it works only on WDS or only on 11s or only on EasyMesh, then it ties you to a specific protocol and possibly box vendors. So those are the things that they should be aware of. Next slide, please. RDKB is an open source initiative that came up to help put all of this together. It is not a lightweight mechanism. It is rather a consolidated version of everything that is needed from a perspective on the gateways. So as you can see here, essentially on top of the OEM and SoC stack, in the kernel, they have all these gateway applications that are running. And on top of that, the CCSP layer. CCSP layer was leveraged from Cisco, open sourced and used by RDKB. And that helps you interface with everything, whether it is TR69 or SNMP or the web UI protocol agent or web protocol agent, all of this. So whichever mechanism you use, there is a means to connect through this. And so it offers the ISP a consolidated means to plug and play every component that there is to home connectivity management. Next slide, please. So now, what does EasyMesh do? What we tried to do was essentially look at going back to the first slide that we looked at in terms of what are the key problems that the customer, the ISP are looking at right now. One, obviously lifecycle management, then provisioning, third, monitoring, more importantly, things like cloud-based management, mesh from a Wi-Fi perspective, IoT and smart home management, all of these, and how do you get visibility into QoE, quality of user experience. All of these are things that matter to the customer, and we said, okay, these are the functionalities that we have to build in. So EnMesh built a hybrid cloud edge architecture to offer just exactly these. So whether it is cloud-based management, mesh infrastructure and management, or even to be able to group customers based on either subscription pattern, geographies, whatever the case may be. Privilege management, like I said, in the TR369 case, also they needed to do this because different types of controllers can have different privileges. Captive portaling, OTA upgrades for lifecycle management, having multiple SSID support, telemetry and enablement for machine learning is another important piece that we wanted to bring in, because that's how your user experience is going to be redefined. So lastly, the application aware performance is a big piece of the puzzle that needs to come in, because in order to provide quality of experience from a user perspective, you have to understand what is going on the client device, be able to detect the application and be able to tune the performance to those application needs, sort of along the lines of possibly even how Arista talked about it in some ways. Finally, the security aspects. Security is a common for everybody, so that needs to happen. The thing that made EnMesh stand out was essentially we tried to make it chipset agnostic, mesh protocol agnostic, and we said we are a no technology religion. We we don't care which middleware you have preferences for or data models. We will help integrate with all of those. The last slide, please. Next one. Yeah, so what can EnMesh do from a sample deployment perspective? So we could essentially interface even with a RDKB type middleware. So interface with it for taking to the carrier, so that the Wi-Fi stats, config, and all of that management and monitoring can go back and forth. So from the NL811 layer, essentially think of having a RDK abstraction adaptation layer that we create, and there will be a EnMesh agent sitting inside the RDKB stack, and it will essentially talk to the RDKB mesh agent as well as the data models, and be able to store data, manage data, and provision configuration. So, but it will also talk to the EnMesh cloud so that it can interact directly for the intelligence that it brings from an adaptive network intelligence standpoint. And because of how this is layered, as you can see, what sits below this, below the NL layer, all the mesh protocols are all abstracted from this. That is what makes it easy for customers to move forward. Next. So thank you very much, everybody, for listening in. I'm happy to take questions.
Yeah, thanks, Sudarshan. There is a question from the audience, but before I even get there, what do you, I mean, you have not said much about the I would say elephant in the room, Plume and OpenSync. What do you think that trend is going? I mean, can you comment anything on that? Yeah.
So OpenSync is at this point supposed to be an open source initiative, and so decoupled from Plume in itself. Yes, Plume created it. It is decoupled from there. But like I said, just like RDKB or TR369, Plume also is yet another initiative. It gives people a variety of choices to go with. What distinguishes Plume from possibly the other ones is that they also try to go into the network side of things to create a software-defined network. So Open vSwitch type integration they have done. So purely from a home network management standpoint, how big of a difference it will make, I don't expect that to make a big difference in itself. So largely everybody is going towards the same goals. In my opinion, it is more a marketing strategy from a Plume standpoint, a good one at that. Ensure that the adoption is there, code access if they have to switch over. But
okay,
all
okay. So there's a question from the audience.
Yeah, sure.
Arvind, what is the difference between Web UI PA and Web PA? I think this was in one of your, I think the RDKB slides. So maybe I can go there if you would like me to.
Yeah. So basically, these are all protocol adapters that are defined in RDKB. So each is essentially so. The Web UI PA is purely from a configuration management perspective, but Web PA is often others with it.
Okay, thanks, Sudarshan. So thanks for your time.
There's one more question, Shrikant.
One more question. Okay. How much sync is between EasyMesh and NMesh? Varun's question. Sudarshan, your voice is a little choppy.
NMesh sits on top. NMesh on top of EasyMesh. So 11S or WDS. We will work with for example, as a as a communication mechanism. So across all the agents, we will use it to communicate, but the intent is NMesh.
Okay, thanks, Sudarshan. It looks like we have had some audio problems. So I think we'll, in the interest of time, we'll close this presentation right now.